Hi everybody, greetings of the day. Today we are going to solve some previous year questions from polymer chemistry, and you'll be able to see that if you attend the sessions of polymer chemistry, you will be able to do each and every question which is being asked in the competitive exams. Okay, so I have sorted a few questions in this assignment, and in the next assignment we'll be completing all the previous year questions, like next one or two. Okay, so let's start. So these are all the easiest questions have been compiled in this assignment. Okay, so this is the beginner level. So the first question is, there are several types of mean molar masses for a particular polymer, and they are dependent on experimental methods like options are osmometry, light scattering, and sedimentations. We have to match them. So already we know that osmometry is the technique that is used for determining the number average molecular weight. So one matches to Mn. So if you can see, it's not option A, it's not option B. So the number average molecular weight is found with osmometry. The next one is light scattering, which is used to find weight average molecular weight. So MW matches to 2 and MZ matches to sedimentations. So the correct option over here is C. So this is not the only time where they have asked this type of question in 2011. Later on also this question has been repeated again and again. So please mark this question as important. Next one. During the addition polymerization, the reaction proceeds via free radical mechanism. We have already learned the example of how ethylene becomes polyethylene, and the correct option is option B. Okay, next one. The intrinsic viscosity depends on molar mass as intrinsic viscosity is equal to some constant K into viscosity average molar mass raised to A. So this is actually the formula. They have given this formula already. The empirical constants K and A are dependent on it's dependent on polymer solvent pair. Option C is the correct answer. So I request you to kindly watch the sessions before doing the videos. So everything is covered in the sessions, after which you will be able to do this very smoothly. Next one. The correct expression for the product of Mn into Mw, where Mn bar and Mw bar are the number average and weight average molar masses respectively of a polymer is very easy. So Mn, we know, is equal to sigma Ni Mi divided by sigma Ni. Correct. Now, into Mw bar is what we need, which is sigma Ni Mi square divided by sigma Ni Mi. Now, they have asked us to take the product, correct? So, Ni Mi divided by sigma Ni into sigma Ni Mi square divided by sigma Ni Mi. So, if you can see, these gets cancelled. And sigma Ni Mi square divided by sigma Ni. Now, sigma Ni is the total number of molecules present, and you can write it as sigma Ni Mi square divided by N. You can write it like this as well. And that is what is given in option B. Can you see? Sigma Ni Mi divided by N is written as N inverse. Correct? It's not option B. Here inverse is missing. It is option B. Option B is the correct answer. A good question which was asked in December 2015. Next one. The Mark-Homwick equation, which is equal to eta km to the power a. Now, this is the second question in the same assignment, and now you know how important this equation is. Mark-Homwick equation. It is very important. Okay. So what is this used for? So this M stands for viscosity average molecular mass. Option C. It is used for viscosity average molecular mass. C. Next one. For a monodisperse polymer, The number average molar mass and weight average molar mass are related by. So we already know that the polydispersive index, PDI, the polydispersive index, PDI of a polymer is written as NW bar divided by MN bar. This is how it is written. And given that it is monodisperse, if it is monodisperse means it will be equal to 1. If it is bidisperse, it will be equal to 2. So here it is monodisperse, so this is going to be equal to 1. Now you can simply rearrange MW is equal to MN bar, and hence correct option is C. Option C, where both of them are equal. Okay. Next question. This is a very nice question. The dispersity of a polymeric sample is, again from PDI. So we know that PDI is equal to NW bar divided by MN bar. Now this is simply how you write the notation. That is all. Okay. So let's try. Now what is sigma, what is MW bar? That is equal to sigma Ni Mi squared. So here it is summation of Mi square divided by sigma Ni Mi divided by, or I'll write it over here, that is much more easier, sigma Ni Mi divided by sigma Ni. Now if I rearrange this, I'll get it as sigma Ni Mi square into sigma Ni divided by sigma Ni Mi into sigma Ni Mi. So they have written the formula on the basis of mean of the masses. So what does this mean? If you just write like this, it just means mean of molar mass. Average of molar mass is what this means. Just putting them in this kind of brackets. So over here, if you can see on the top, it is the mean of square of the masses. Okay, you understood, right? It is mean of the square of the masses which comes in the numerator, and at the denominator, it is summation of Mi, which is mean of M, into again mean of M. Correct? So we can write it as mean of M squared divided by mean of M the whole square. Beautifully crafted question. It's option A. Option A. Option A is the correct. All right. Last question again from polydispersive index. So again, important topic. Here it is a numerical question which was asked in 2023. So a particular sample of polymer has 100 chains with molecular weight 1000. So let's write down the data. N1 is equal to 100 with M1 is equal to 1000, 10 to the power 3. And you have got N2, 200 chains with mass 10 to the power 4. And you have got again 200 chains with M3 is 10 to the power 5. Correct. The polydispersity of the sample is, again, very easy. You have to first find MW and then you have to find MN divided. PDI, you already know, right? It is MW bar divided by MN bar. Let's write the formula. Sigma Ni Mi square divided by sigma Ni Mi divided by sigma Ni Mi divided by sigma Ni. So if I rearrange this, sigma Ni Mi square into sigma Ni divided by sigma Ni Mi the whole square. So let's start. Okay. 100 into 10 to the power 3 square, which is 10 to the power 6. Correct. Plus 200 into 10 to the power 4 square, which is 10 to the power 8. Plus 200 into 10 to the power 5 square, which is 10 to the power 10. This is the side. into, you have 100 plus 200 plus 200, which is equal to 500, divided by NIMI square, which is 200 into 10 to the power 3 plus, no, 100 into 10 to the power 3 plus 200 into 10 to the power 4 plus 200 into 10 to the power 5, the whole squared it is. Okay. So for the sake of simplicity, I'm taking 10 to the power 6. 500 is already common out. And I'm taking 10 to the power 6 also outside. So let's see what is there. Or I can take 10 to the power 8 outside. Because there are hundreds in everything. So I'll take 10 to the power 8 outside. Okay. So what I have inside is, this was 10 to the power 6 and I took 100 as 10 to the power 2. Okay. So 10 to the power 6 into 10 to the power 2 is 10 to the power 8. I have taken that outside. So here you have 1 plus 10 to the power 8 taken outside. I have 200 here plus 10 to the power 8 is only taken outside. So I have 200 along with another 100 which is left. Correct. This much is there, divided by I can take 10 to the power 5 from here outside as well. Whose square is there? Or let's do it. I'll use I already have the answer. I'll just solve it. At the bottom, what you have is 10 to the power 5, correct? Plus 200 into 10 to the power 4 plus 200 into 10 to the power 5. Correct. Is what we have. And after doing this, what I'm getting is 221 into 10 to the power 5 square is what I'm getting. Okay. Now, if I take this 500 into 10 to the power 8 into, if I add the terms in the numerator, it's going to be into, sorry, divided by, correct, na? 20,000, yeah, 201. And then I have 221 square at the bottom to 10 to the power 10. Okay. So finally I have 500 into 2021 divided by 4884100. Okay. So my final answer, what I'm getting is 2.068 is the PDI that I'm getting. Let's check the units. Sorry, let's check the options. Okay. So it is matching with exactly option C. 2.068. Option C. Okay, it's a bit lengthy question, but then, the formula is very easy. We need to just plug in the values and find the answer. Option C is the correct answer, right? Okay. All right, so with this, we'll stop this assignment. It was a very easy peasy assignment. In the next assignment, we'll slowly increase the level of the questions. Okay, so thank you. See you until next.